All right, so today we're going to talk about how we can translate work problems into equations. So the nice thing about when we write an equation from a word problem is it's going to have three parts. 1, 2, 3. It's going to have some number that needs to be multiplied or divided. Very rarely is it ever divided. Most of the time it's going to be multiplied. Second is going to have a number that's going to be added or subtracted. And the final number is going to be the end result, the total. Typically it's a total, but it's always going to be the end. So in my question, I got my three parts. There are 8 math classes in 7th grade. 7 are equally sized, and the 8th class has 32 students. If there are a total of 221 students in the 7th grade, how many are in each of the equally sized math classes? So my end result's my total number of students, 221. That's what my expression is going to equal. Now, if there are, where does it say? 7 equally sized classes. That's 7 of them. Well, you got to think about it. If there's 7 classes, we're going to end up multiplying. But how many students are in each class, we don't know. What we don't know, we put as X. And then finally, there's 32 students in the last class. That 32 is going to be what I have. Now, you guys are going to solve this on your own after I'm done translating these. You're going to knock out 6 two-step equations and then flip on the back side. Actually, scratch that. Don't solve them. We'll just worry about translating them, and then on the back side we'll translate and y'all will find the solutions for these. But on the front side we'll just translate. Number 2, Nick has $45. He has a $45 gift card. He purchased the same latte 6 times and has $18 left on his card. What was the price of each latte? So once again, my end result, I always like to start with the end result. I feel like that's the easiest number to find. And then it kind of makes it a little easier. Purchased the same latte 6 times. Ooh, 6 times. 6 times. Time sounds like an operation. It sounds like multiplication. So I'm going to put 6 times. Whatever's being multiplied, whatever's happening again and again and again, that's the number that goes with my variable. He has $18 left. Because if I took the price of the latte, find the total for the amount of his lattes, add up what he has left, that's going to equal 45. Sure will. Number 3, Mr. Marcus is splitting a huge new pack of colored pencils equally among his 25 students. After splitting the pencils, he has 4 left. If there were 429 pencils to begin with, how many does each student receive? So 429 is the total. When I say end result, really it's end or total. We see total a lot. The total amount. Now he's splitting this up into 25, he's splitting up the pencils among 25 students. So he's splitting them up 25 times. He has 4 left. Boom. Number 4 is probably the question you're going to see the most. The age questions. The age question is the question that's on your CFA. Beth is 4 years older than 2/3 the age of Milo. If Beth is 14 years old, how old is Milo? 2/3, kind of a weird way of saying that. A lot of times it'll say something like twice his age. When somebody's, you got to think about it, you're put in those shoes. So if somebody's 4 years older than you, they're +4 in years. 4 years older, +4. 2/3 the age. This one kind of is set up a little weird. it'll be set up like 2/3 eggs. Typically, it says something like twice their age. Twice somebody's age would just be 2 eggs. Beth is 14 years old. Is going to be my equal sign 14. Number 5, Ella is selling cookies for $4 per dozen. She pays $10 for ingredients. If she ends up with a profit of $66, how many dozens of cookies did she sell? So my end result is going to end with 66. That's how much money she made. She's selling the cookies for $4 a dozen. We don't know how many dozens she's selling. That's the number that happens again and again and again. But watch this. She pays $10 for ingredients. You gotta think about it. If I'm paying somebody, am I adding money to my bank account or am I subtracting money from my bank account? Paying money is gonna be minus 10. This is one of the rare instances. Not very often do we see, a subtraction. I want to kind of talk about the age question again. Like where it said older than and we know to add. You gotta think about it. If somebody's younger than you, what would you add that or subtract that? Number 6, Mr. Jenkins won $500 in a raffle. He split some of the money amongst his 3 children and had $20 left. How much money did he give to each of his children? So he won $500. That was his total. He split some of the money among his 3 kids, so he took... Oops, sorry, that's my owl clock. Is that it? Oh, there it goes. Oh, that's a loon. Not an owl. My bad. I knew it went one more time. But that's 3x. Okay. And he had $20 left. And I understand what you would think, okay, if he split it up into 3 sections, I would take x and divide it by 3. It's just the weird thing about word problems is we just don't set it up like that. It'll be very, very rare. I don't think I've ever really seen an equation word problem and we've taken a number and divided it into x. It's always going to be multiply. I want to go over another age question. I don't know if there is. All right. Y'all are going to do the 6 on the back. And write your equations and your solutions.